Today what we're going to do is we're going to learn how to solve log equations and exponential equations. Now what you're going to notice is that in an exponential equation, it's an equation if it has a variable in the problem. Okay, the exponent will be a variable. Now, if it's a log equation, it's going to also involve a variable, and you have to solve for it using the properties that you learned yesterday. Remember the addition, the division, the subtraction, division, and the power rules. So, we are going to begin by looking at solving exponential equations. Ladies here. So, with the exponential equations, there's two types. There's two types of equations. Look at question 1 and 2, and then 3 and 4. 1 and 2 are of one type, and 3 and 4 are of the other type. If you can get both sides in the same base, for example, I'm going to show you something off that's not on your page. If you saw something like that, you can have, see this, it's called the one-to-one property. You can cross these 2's out and you're solving for x. So you'd have x minus 3 equals 5 and x is 8. Okay? So if you can get both bases to be the same, that's what you're going to do first. And in question 1 and 2, you can get them in the same base. So let's look at some examples. Number 1, you've got a 16 and an 8 here. How can you convert a 16 and an 8 so they're both the same base? What would be that base? Okay, so you said multiply 8 by 2. So you mean, I think you mean this, 2 to the 3rd power? Is that what you mean? 2 to the 3rd power is 8, and then this is 2 to the 4th power is 16. So you've got to get them in the same base. Do you understand that 16 is 2 to the 4th power and 8 is 2 to the 3rd power? Now they're in the same base. What was that property we talked about yesterday? When you have a power to a power, what do you do with these two powers? You multiply them. So do you agree you have 2 to really the 12x power? Now you can cancel these 2's out because they're 1 to 1. And you've got this equation, 12x equals 3. What's x?
1/4.
1/4. Okay. Number 2. What is the common base? You've got a 27 and a 9. What's the common base? It's 3. How do you convert 27? 27 is 3 to the 3rd power, but you have a 2x out here. So it's really 3 to the 6x. Now how are you going to convert 1/9 into base 3? Well, isn't 1 over 3 squared 9? 1 over 9, isn't that right? And then can't you bring this up here and make this 3 to the negative 2 power? Now they're in the same base. So sometimes you can manipulate equations so they're in the same base. So cross these 3's out, and you have 6x equals negative 2, and then do what? Divide by 6, and you get negative 1/3. Do you get this? Okay, I want you to flip your paper over, and using that same rule, 1 and 2 are like that. So let's do 1 and 2. how do you get, you've got a 4 and a 64. How can you rewrite 64 in base 4? Is there another name for 64 with a base 4? 4 to the 3rd power. There you go. So we can do this. 4 to the 3x is equal to 4 to the 3rd. Then what?
Into the 4 there.
Cross out the 4's and you get
X equals 1.
x is 1. Okay. How about number 2? Can you make 32 in base 2? What is it? 2 to the 5th power. So we've got 2 to the 5x plus 1 equals 2 to the 5th power. Then what do? Cross out the 2's, and you have this equation, 5x plus 1 equals 5. Then what? Subtract 1, and then divide by 5. So 4/5 is the answer. So do you understand that concept? If you can get both bases to be the same, you do so. Flip this back over. What if you can't? Here's an example of when you can't. I can't turn 285 into base 15, or I can't make these in both the same base. Like for example, if you had something like this. If you had 2 to the 3rd power equals 5. Oops. I want to make that an x. Sorry, 2 to the x power is 5. You can't make 2 and 5 in the same base. So what would you do in this problem? You will rewrite this in log form. That's if you can't get them in the same base, you're going to rewrite it in log form. How do you rewrite this in log form? The log of 5 base 2 is equal to x. This is where the calculator comes into play. How do you do log of 5 base 2 on your calculator? Can you type it in? Okay, so now that's what you're going to do. On these problems where you can't get them in the same base, you're going to rewrite this. How do you rewrite this in log form? What does it look like? Log of 285 base 15 equals 3x. You got to know the conversion. Now you take your calculator. If you have the Inspire in front of you, you're going to type log, hit control log, and then type in the 15 in the little box and 285 in the bigger box. Whatever answer you get, what do you do with that answer? Because I'm trying to solve for x. What do you do?
Multiply by 3?
Not multiply by 3, but divide by 3. You're going to divide by 3. What did you get for an answer?
0.69.
What was it again?
0.69.
0.696. So this answer, when you do it on your calculator, and I will demonstrate it right here, you're going to hit control log.
You're blurry.
I'm blurry. I'm blurry.
I'm blurry.
It's going in and out. Is it still blurry to you?
Kind of.
I don't know why.
There it is.
Okay. So 15 is your low box, arrow to 285, bigger box, hit enter. That's what that is. The log of 285 base 15 is 2.08, and then divide by 3. You can just say divide 3, and there's your answer. What do you think you're going to do? Now, number 4 adds a little twist to the story. What should you do? What do you think you're going to do?
Subtract by 8.
Very good. So your instinct is right. You're going to get rid of that 8 by subtracting 8. So after you subtract 8 to both sides, what do you think you're going to do now? Rewrite it, because I can't get them in the same base. You've got the log of 2 base 3 is equal to x. So type that in your calculator and tell me what answer you get.
0.631.
Yeah, 0.631. You get this. So we've got two things under our belt now. Exponentials. If you can get them in the same base, you do that. And if you can't, you rewrite it. So flip over. I want you to do 3, 4, and 5 right now. 3, 4, and 5. So how do you do 3? Rewrite it. Log of 3 base 2 is x. And what did you get for an answer?
1.6.
1 point what?
6.
Now it says round to the nearest 10,000s.
Oh.
So I'm gonna say, let's just round to 1.585. What would you do to number 4? Good, subtract 8. Now the first thing you should look for is,
Why not?
can you rewrite both sides in the same base? Can you? First use your brain before technology, okay? That's the rule of thumb. Brain comes first. How do you write 1,000?
10 to 3rd.
There you go. I did not have to lift a calculator. I did not have to push a button.
I didn't have to write that stuff.
Huh?
I didn't have to write that stuff.
Yes, some don't.
I went right to x equals 3, because
Yeah, some people just know it, and that's perfectly fine. That's perfectly fine. But the whole point is, there's a time and a place when to use this calculator. This is not a calculator problem. But this one is, number 5. I can't get 9 and 66 in the same base. Look for numbers like 81 and 3 and 27 and 64. And those are the kinds of numbers that you'll start to see the pattern, or 1,000, 100, 0.001. Those numbers you can write in the same base. But this one I can't. So what would I do right now? Convert. Log of 66 base 9 equals 2y. Whip out the calculator now. You're going to type in log of 66 base 9. You're going to get 1.907. And then what do you do with that answer?
Divided by 2.
Divide by 2. And y is equal to 0.953. Okay, I bet you can do number 6. It's a story problem, but it's the same, it relates to what we're just doing. It says the equation y equals 6.72 times 1.014x models the world population in billions. So the equation is in billions already. So it's in billions of people. So this is, if you remember when we started working with these, this is an exponential growth problem. Do you remember what this number is? That's the initial amount, the y-intercept, and that's going to be in billions. So it's really 6.72 billions of people. So they want to know, find the year in which the world population is about 8 billion. So we want the population to be 8 billion. So we're going to put an 8 here for y. Now, how do you think you're going to solve this? Now, some of you might want to rewrite it. So the exponent and the base are on the left side, and that's okay. If you are, I do all the time. I always rewrite it.
Divide by 6.72.
Yep, you got it. You're going to take 8 and divide it by 6.72. And what do you get when you divide? You get 1.109.
No,
1.1.
1.19, yes, I'm sorry. You get 1.1904, actually. Now, how do you convert this to log?
log of 1.19 base 1.014.
You might need to leave a little bit of room there. So on your calculator, type what? That, just like that. And your answer, I think, comes out to be about 12.5. So-
Yep,
Did you get that, 12.5?
yep.
So let's see if we understand what this question is asking you. So after the year 2000, you would add 12 and a half years. So in the year 2012, in between like 12 and a half years after that, the world population will be about 8 billion. It's growing. So in 2000, it was about 6.7 billion, and then in 12 years, 12 and a half years, it'll be 8 billion. Does that make sense? Does that sound right?
And it
Okay.
says find the year.
Find the year, so what would it be? We just said it, what would be the year? 2012, in between 2012 and 2013.
But if they're asking the year, that would be 2012.
Right. Between 2012 and 2013. Okay, next. Go to the log problems. Now, there's two ways to solve log problems. These are log equations. Again, if you have, there's gonna be two types. If I say log of x minus 3 base 2 equals log of 5 base 2. See how these are both the same base, log base 2 and log base 2? You can, just like you did with the exponential ones, you can cross those out. So if this happens, you can cross them out 1 to 1. So you would have x minus 3 equals 5, and then add 3, you get 8, okay? But if you don't have a log base 2, or whatever the base is, if you don't have one on each side, you can't cross them out. What you would do in this case, let's say I gave you this problem. Now this one, I don't have a log on both sides. I don't have a 1 to 1. I can't cross out that log base 2. So now what did we do with the exponential ones? We wrote them in log form. What do you think you're going to do with the log one? Rewrite it in exponential. How would you rewrite this in exponential? 2 to the 5th power equals x minus 3. What is 2 to the 5th power?
32.
32, and then add 3, so you get 35. Okay, so that's what you would do. So check out number 5 on the notes. This is an example of one that doesn't have a log on both sides, so I'm going to rewrite this. How do you rewrite this? What's the base? I don't see a
10.
base. It's a 10. So what is 10? Rewriting this, 10 to the 2nd power is 5x plus 2. What is 10 to the 2nd power? 100. Then what? Subtract 2 from 100, you get 98. And then divide by 5.
This calculator refuses to do so.
And what do you get for an answer?
His letters are stupid.
Decimal.
19.6.
19.6. Okay, number 6. Now we've got those properties that we learned yesterday. What property are we going to use for number 6 on the left side? It looks like a subtraction. You divide. So shrink, that's another tool you have in your box. You're going to shrink the left side. How do you shrink the left side? Log 2x squared over 5 equals 1. Okay, that's that division, the division property. Now we're gonna rewrite this. What's the base? 10. So it's 10 to the first power, which is just 10, equals 2x squared over 5. Now what do you do? 10 times 5 is 50. What else?
How about you
Divide by 2, you get 25. Then what?
square root x equals
Square
5?
root and x is plus or minus 5. Now, whenever you're solving any log problem, you're always going to pick up that answer, 5 and negative 5. There's two answers for this. And you want to replace it into the original problem. You want to make sure you never have a negative number in this spot right here, or a 0. So if I put 5 or negative 5, whether I square a positive or negative, I'm going to be fine. So there's no extraneous solutions in this one. How about number 7? How am I going to condense? I want to condense this side right here. I need to condense it. What property did we use yesterday that involved a plus sign? What was the property? So what do I write on this side? X minus 3 times x equals 1. Okay, now, I don't have a log on the other side. What's the base here?
10.
So how do we rewrite this one? 10 to the first power, which is 10, right? Equals x minus 3 times x. What do I do next? Distribute the x. And I know you guys know what to do next. Swing this 10 over. And what do we do? Factor. Always factor anything with x squared. What do you get? Minus 5 and plus 2. So my possible answers are 5 and negative 2. But when I pick each of these answers up, 5 is fine. 5 minus 3 is 2, and 5 there is fine. But the negative 2 poses a problem. I can't have log of negative 2. It's undefined. Can't do it. Can't have it here either. So guess what you're going to do with this answer? You're going to cross it out. Questions? Okay, and I want you to flip to the back. Number 7. Now, there's something you can do with that too. It says 2 times log of x base 10. Does anyone think they know what we could do with that 2? The 2, you have two options. You can actually either make it a power of x, but there's actually something easier you can do with that too. Yep, divide both sides by 2. You can do that here. So divide this by 2. So you have the log of x equals negative 1/2. What's the base here? 10. So this is 10 to the negative 1/2 power. And just take your calculator, and what is 10 to the negative 1/2 power? It's about 3.316. Questions on that? So you can, that's another thing you can do, is get rid of that 2 by dividing, if it's in front like that. Number 8, what do you think you can do with that 4? Subtract it. Now, if it were in parentheses, then you can't. Okay? If I had this in parentheses like this, then you would go to rewriting it. But I don't see a parenthesis there, so this is fair game to subtract 4. And that's exactly what I'm going to tell you to do. Subtract 4. Now, how do you rewrite this in exponential form? What's the base?
10.
10 to the
4.
10 to the 4th power is 4. I'm sorry, is x. Is 4, is x. Now, do you know what 10 to the 4th power is without using a calculator?
10,000.
It's a 1 with 4 zeros. A lot of people will put a 10 with 4 zeros. It's a 1 with 4 zeros. So think of it as 10 times 10 times, there's 4 tens being about 4 of them, it's about 10,000. Okay? Next, what do you think you do with that 3? Uh-huh. This is a calculator problem. What is 1.5 divided by 3? 0.5? Okay, then what? What do you do next? You tell me.
You change it.
Change it to what? Now, just so you know, what's another name for 10 to the 0.5 power? What's another name for 10 to the 1? These are all the same problem. These all mean the same thing. So however you type it in your calculator is fine. What'd you get? 3.6? 1.6? Okay, number 10, I'm going to ask you to convert this to base 2 because it's a crazy number. Make them base 2. Make this problem log 2x base 2 plus log of x base 2 equals 11. Okay, so what do you do now?
Cancel the logs out.
Nope, you can't cancel them out, but you can condense this side. You can write this side as log of 2x squared base 2 is 11. And that's even going to be crazy. 2 to the 11th power. That's not too bad. Okay. Now you're going to convert this to 2 to the 11th power is equal to 2x squared. What's 2 to the 11th power? It's 2,048. You know what you do now? You're going to divide by 2. You get 1,024. And I'm running out of room, so I'm going to write up here. Now what do you do? Square root. Now you're going to get 2 answers. Plus or minus. What do you get? Plus or minus 32 when you take the square root. But one of these answers is extraneous. Which one's extraneous? The negative 32. Why? Because you can't take the log of a negative number. So the only answer that works is 32. How are you going to convert number 11? Did you have a question on this one?
Yeah, I was just looking at that, their bases were not the same, so I figured it out before I asked. I saw the 2s, thought they were the same base, but they're not.
No, this is a 2x squared. Okay, number 11, how do you condense this left side? Division. So it's 5 over 2x. And what's the base? 10. So rewrite this as 10 to the first power is equal to 5 over 2x. Then what? You're going to multiply. You get 20x equals 5. And what's x? It's 5/20ths or 1/4. Questions? Okay, now flip to the front. We've got a story problem here. And this kind of relates to what we did in section 7.1. It says your MP3 player, it starts off, the initial amount of memory it has is 126 million bytes. And each month that you plan to use it, you lose 5% of the memory. How many months will it take for you to use a quarter of this memory? So, you're gonna use this formula. The initial amount is 126 million. Now, if you use a quarter of that amount, what is that gonna be? A quarter of the amount will be,
0.25.
I got a different answer. What'd you get?
0.25 times. 3.15.
Yeah,
Times
3.
10 to the 7.
So I got, the answer is gonna be 331,000. 31 million, I'm sorry.
Wait,
Now, do you remember the formula that we use for exponential growth and decay? So the initial amount times 1 minus the R rate. And then time is gonna equal that. So that's what you're gonna, that's what you have here. So your initial amount was 126 million. You're losing or using 5% each month. So it's your multiplier here is gonna be 0.95. So what you're gonna do now, you've got 126 million. Now, does anyone know when you divide, I know you know to divide these, right? Do you know what you can do with those zeros? What can you do with these zeros? If you put this underneath here, what happens to, we've got 1, 2, 3, 4, 5 zeros. You can cross out with these 1, 2, 3, 4, 5. So when you type this in your calculator, you're gonna do 315 divided by 1260. And tell me what you get. So you have 0.95 t equals. And this should end up being 1/4. Did you get 0.25? Because it's 1/4 of that amount. And we knew that, that's 1/4 of that amount. So now how would you solve this problem? I'm gonna convert this to a log problem now. So this is gonna be the log of 0.25 base 0.95 equals t. So it's the log of 0.25 divided by the log, 0.95. So on your calculator, if you have the Inspire, you're gonna type log in the small box 0.95, in the bigger box 0.25, and you should get 27.03. Tell me if you get that. You get that?
Yep.
Okay, now one more, flip to the other side. As a town gets smaller, the population of its high school decreases by 6% each year. The senior class right now has 160 students. In how many years will it have about 100 students? Write an equation and solve the equation without graphing. So, what's our initial amount? 160. 160 times, it's decreasing by 6%, so 1 minus 0.06. How long, we don't know, but we want to know when we'll have 100 students. So what would you do? What's 100 divided by 160? And this is gonna be 0.94, can I just do that too? I got 0.625. So everyone, you did 100 divided by 160, you get 0.625. And then turn this into a log problem. It'd be the log of 0.625 base 0.94 equals T. What'd you get?
7.6.
I'm gonna say 7.6 inch years. So in about 7.6 years, our population is gonna go to 100 students. You get this? Everyone got this done?
Okay.
Okay,